Chalo, I'll start with a small prayer, and if anybody is interested to know why I started with it and what's the meaning, you can ask me towards the end. Okay. Uh, Anytime if my audio is um, bleak or anything like that, just let me know. Om Ajnanatimirandasya Jnananjana Shalakaya Chakshurunmilitam Yena Tasmai Shri Gurave Namaha. Now, essentially, we are here to resume our discussion on what are those nice rules to keep in mind when we are doing analyses. And the channel, I think, has two prior videos, and the recap that I'm about to give in a minute is very much in detail present in those videos. If desired, have a look at it. So, the rules that we covered so far, and I'm just skimming through it. The first rule, search your feelings. It's essentially about check whether you are biased towards a particular outcome before starting the research altogether. Because your bias, your inherent bias, your emotional or psychological bias as well, can make you interpret the data in a very um, uh, distorted way. The second rule, ponder your personal experience. It essentially is about try to synchronize what you are seeing at the ground level with what is there in the global level. So, what you could be witnessing at the ground level, the field level, we also call that, may be different from the average statistic, but still both of them may make sense. So, don't get immediately judgmental about what you are seeing is completely complementary of what the higher authorities are reporting to you. Both of them can make some sense. The third rule is maybe it's my favorite, avoid premature enumeration. It essentially means before you are starting to count anything, keep the definition in mind. Just make sure you know what you are counting. And more so, if multiple people are doing counting, uh, they should ensure that they are counting the same thing. We had a very interesting example over here where there was an apparent difference in mortality rates between two hospitals in it was United Kingdom or England. But they turned out it was actually a difference in the way they were recording the birth and deaths of children. So it was not actual difference, it was just they were counting different things. So this can save you a lot of time. That's why it's my favorite rule. The fourth rule, I think most well worded of all, step back and enjoy the view. It essentially talks about the very important thing of having a sense of scale. This I personally find very lacking in general. Whenever we are quoted a big number or a number that we consider big, we think that we are overwhelmed essentially. But what we should do is when somebody is giving you a big number, you should try to sort of research the market and see similar numbers out there. Suppose it's like, let me put it like this. If you are being offered a salary of, let's say, 1 crore a year, and you are just a student, you have not earned at all. For you, perhaps 1 crore is a very big number. But maybe the market average is 1.5 crore. So if example, you have these numbers in mind, you can negotiate situations better, not just for your salary, but in other situations as well when you are doing analyses. The fifth rule, which we discussed, was get the backstory. This is essentially about keeping in mind that whatever data that you are seeing in front of you may have gone through a kind of filtering. And we had a very good example. Not it was a real life revisit to the work of the famous statistician Abraham Wald, who coined the term survivorship bias, if I'm not wrong, or his work led to the formation of exactly. Yeah. So World War II, he's tasked with finding the critical area of the plane where safety investments need to be made. The data suggests that it's probably the middle part of the plane, the wings and all. But he says the engine. And when people ask why the engine, the data doesn't show any, damage marks to the engine, he said a very smart thing, a common sense and a smart thing. He said because the planes that are getting hit in the engine are not coming back, so you don't have the data to tell that to you. So the data that you are seeing is kind of filtered. So it's perhaps the most difficult rule to keep track of, because we often take the data in front of us for granted without giving it much thought about the filtering process that it may have gone through. So it's very crucial to keep in mind. Rule 6, I think because of time constraints, we couldn't discuss. So I'll give a brief overview. Now we'll try to discuss 6, 7, 8, 9. There's a 10th rule as well. You may be wondering why it's not written on the screen. I'll get to that later. And as before, this thing that you see over here towards the left side, some statistical notation, it's linked to the rule. And when I'm done describing the rule, I will tell what it is. But you can make your guesses. So ask who is missing. It's where the case study over here in the book is very interesting for this. So there was this professor in the 20th century, Solomon Asch, Stanford University, if I recall correctly. So he did a very interesting experiment. He called, like he invited a group of people, and there were three lines as you see on the screen, A, B, and C, and there is a fourth line separate, X. The experiment was simple. What do you think X resembles to the closest? Which line, A, B, or C? So if I had to ask you guys this question, you see X, you see A, B, C. What do you think X is closest to? Okay, in the interest of time, I'll just give it away. Obviously, it's B. I mean, maybe it's not that obvious, but it looks B. So what happened was, it was the experiment was rigged. Only one person was actually being experimented upon. The other people were kind of stooges, or people that were deliberately implanted. This is how psychological experiments, happen. So when you are somewhat asked to participate in one and they tell you that the experiment is something, it's probably something way different than that, or something internal is going on which you are not made aware of, because it's a part of the experiment to keep you in the dark. So the thing is, everybody said C, which was the wrong answer. But the person who was logically saying B, the person felt the pressure that because everybody's saying C, maybe it's C. So they changed their answer. This, on a side note, this is what is called conformity, which is whenever you are a part of a group, even though you may be taking a certain right decision in some logical sense, the overall decision of the group can affect you because you feel the need to be a part of the group. It's something perhaps very natural, maybe linked with our fear of death and survival and all that. An interesting discussion for another day. Now, interestingly, Solomon Ash had a student, Stanley Milgram. Same thing. He did this experiment where there are two people, three people actually. One person is the teacher, other person is the student, and the third person is kind of a research assistant or something, research conductor. So the subject or the teacher is supposed to give an electric shock to the student if the student fails to answer a question correctly. And there are levels, 20 volt. I don't know the voltage numbers, what are lethal and not, but there's a increasing degree. The more you increase that, the more painful the shock is going to be. Now, before the experiment started, it was made clear to the teacher or the subject, in this case, that um, you don't have to continue the experiment at all. You can stop anytime you want. Mm, you will be given the money because in these experiments you get money to participate. So you no pressure. But what happened was, So this teacher is asking the question, some answers are right. When there is a wrong answer, there is an electric shock and the student screams in pain from the other side of the screen. And the teacher, you know, is told by this other person, this research kind of person, that please continue with the experiment. And the teacher feels the pressure to continue this question answer session. And this person also tells the teacher to increase the shock, this increase the shock intensity. Now remember, in the beginning, it was made very clear that the teacher did not have to increase the shock voltage or told the teacher did not even have to give the shock. But just because a person at the back of his neck wearing a kind of authoritarian coat was saying, the teacher continued to give shocks. And in some cases, the teacher was also enjoying. There was a kind of sadistic pleasure on giving shocks. But again, the twist was that the student was fake, because obviously there will be a lot of human rights issue to do such an experiment, right? The student was just pretending to receive the shock, but the teacher did not know that. So the person in was very well sort of conditioned to believe that the shocks are real. Despite knowing the shocks are real, the person, continued to do that. So that revealed something very dark about the human nature, right? So this is again a concept of conformity only. Like, you may be a good person, but under the face of authority, maybe you will do things that you otherwise wouldn't. And you may even start to enjoy it, something very dark. But this case study was not at all about these experiments in that sense. The very interesting thing was that this was an experiment. These experiments were, I think, a part of Stanford University, but still, no women were included in the research. It was like completely men based. And like, this is not the first time that this has happened. There is this book, as you see on the screen, by this person, Caroline Criado Perez, who has done an extensive research on how, when people do experiments, intentionally or unintentionally, sometimes they leave out, uh, considering that a part of the people who participate are going to be females. And she has brought it out quite well in that book. And now the problem is, obviously there is discrimination of inclusion, there is sexism perhaps, but even from a research point of view, it biases your research, because if you are completely shunning a part of data, or like you are supposed to do experiment on three variables, but you pick only two, then whatever inference you make can be incomplete. And in this case, the conformity rates that were estimated were kind of off, because conformity rates in men and conformity rates in women are different. So if the researchers were very inclusive or aware at that time, they would have made this decision to be very, careful about the kind of data that they are arranging for the experiment. And this is why the rule, ask who is missing, as in ask what variables or factors in your data set or your experiment could be missing when you are doing any kind of analysis. And let's discuss more on it. So this person, David Hand, coined this term called dark data, which is essentially data that you don't even know that exists, intentionally or unintentionally, probably. So the problem with this dark data is, I find it quite cool. In my mind, I visualize it like dark matter. I mean, I don't know what dark matter is exactly like, but I assume it's very different from matter. And I do know that when matter and dark matter meet, they annihilate each other. But anyway, dark matter is a mystery. So is dark data. What happens is, when we make machine learning algorithms, or any algorithms for that matter, which are trained on a skewed sample, on a biased sample, when they are making inference, their inferences or conclusions will also be biased and skewed. Very simple as that, right? So I very much like this line on the bottom. The algorithms that analyze big data are trained using found data. So essentially, what you consider as your complete data is for all practical purposes just found data, the data that you are aware of. There may be data that you are not aware of. Maybe it's not nothing intentional, but maybe you did not do your due diligence and you missed out certain variables. So it's very important to ensure that your training data set is very representative of the population that you're trying to model on. Like the selection bias and sampling error is being illustrated in the photo on the screen. So this can give very skewed results. One interesting example was that some guys created this app called Pothole or something. It was a very nice calibrated app which could help you look at the uh, based on what the geo sensor, it could identify which road area had potholes in them. It was somewhere in America this was deployed. But the problem was because this was only deployed in iPhone or iStore or something like that, it was only a certain rich segment of the population ran that app. So what happened was the areas that got improvement in construction were only affluent areas. So again, here the makers of the app had this assumption, right, that they would cater to the entire population, but essentially they ended up the data that was processed was only from a particular segment of the population. So it can get very nuanced. So we have to be very careful. This was the sixth rule. Ask who is missing in your data or what is missing in your data. And the connection with this statistical notation is this beta symbol is essentially the power function. Usually, when we do hypothesis testing, we have power functions with us, and it is illustrating that your power on the basis of your complete data is obviously going to be more than the power on the basis of just a limited sample of the data. So when you are doing inference of any sort, it's very important to have the complete data set in place. Maybe we'll always miss out something. It's in an ideal world, we won't miss out anything, but there can always be something we miss out. But it's at least the mindset to try to capture as much as we can. Okay. Now onward to rule 7, which is uh, demand transparency when the computer says no. And let's see if you guys can make out the statistical notation in connection with the rule before I give it away or not. Okay. Uh, when some years back, when this big data term was relatively new, there was this notion or belief amongst many researchers that now that we have immense amount of data, we will just be able to do any kind of predictions. And the line that represented the thought was like with enough data, the numbers will speak for themselves. You don't have to worry too much. So we have three examples in front of us. All of them are real, by the way. Google flu trends was some, you may not have heard of it, but even I did not before reading this book. In 2007 to 9-ish period, the researchers released this functionality called Google Flu Trends to predict the influenza spread. And then there were researchers who were trying to make algorithms to detect skin cancer. And then there were very simpler algorithms to predict huskies or dogs. They had a large amount of data with them. Like data size was not an issue. But can you guess what can go wrong? Maybe you have seen the third picture. I'll give like 10-15 seconds. So let's focus on the third picture because the other two are difficult. What can go wrong if you're training a model to classify whether the animal is a husky or a dog? What do you think can go wrong, even if you have a large data set? In the interest of time, I'm again giving it away. What can go wrong is you can just get a snow detector. Uh, so what essentially happened with each of these three algorithms was that the Google flu trends, the researchers thought that they had built a flu trend detector, but essentially they found that there was a lot of correlation with it detecting winter. So they used machine learning algorithms, but they did not exactly know how the machine was learning. So they did not realize it until it was late that they had just built a mixture of a flu detector and winter detector. So what the reason we don't hear about Google flu trends is because as a project it was discarded because it was going after some time it predicted way off the charts. As you can see the line towards the end in the photo, it's translucent in some sense, but you can see that the blue line just spiked too much, whereas the red line didn't. So it started predicting haywire. For the cancer detection algorithm, w- the coincidence was that each of the most of those photos had a scale or a ruler in them. So the machine learning algorithm actually was a ruler detector, and whenever there was a ruler in the photo, it would say cancer. And on huskies and dogs, because most of the photos were associated with snow, huskies were in snow. So whenever there was snow, it was predicting husky. So what essentially this raises is if we have no idea what is behind a correlation, we have no idea what might cause that correlation to break down. Because in each of these cases, it was initially it may have been working well because they did not realize what it was, what the correlation was. And when there were some samples which were kind of offbeat, the correlation broke down and the classification was not good. And there are more case studies as well. For instance, Amazon tried to uh, have this model to shortlist candidates on the basis of their CVs, and this is something that does happen in the industry. So, but what they ended up doing was the algorithm started to give more preference to men. The reason being their training data was in the past, right? And in the past, because of circumstances, men were employed more in the workforce than women, at least in a registration sense of way. So the algorithm was very neutral in the sense like it saw in the data that there were more men in the past, so it gave more preference to men when it saw the sex or gender in the CV. Similarly, this was very interesting. The picture on the right. Everybody of us may have learnt in our textbooks in the past, maybe not everybody, but many, that the correct human temperature, normal human temperature is 37 degrees or something like that. And there is a reason behind this because in 19th century, about 200 years back, I think, without computers, this person, Carl Wunderlich, made 1 million measurements roughly of body temperatures. But the thing was, the thermometer that he used was probably off by 2 degrees. Like, very anticlimactic because you can take a lot of data, a lot of temperatures, but if your thermometer is broken, if your setup is inherently biased, you will just get very precise to the wrong answer. I really like that mean square error equals to bias plus variance equation that we have, which says that you may increase your sample size and your variance can go to zero. But if it is inherently unbiased, you will just get very sure about the wrong answer. So it's very anticlimactic in that sense. Yeah. So it's very important, especially given that I work in a regulated space, a finance company. More important for people like me to be able to explain what our models are doing because we face strict scrutiny, strict regulation on why your model is giving 0.7 for this case and all that. Are you covering all the cases? And there are a lot of explainability tools for machine learning algorithms out there as well. I don't know about neural networks much, but we used XGBoost, and there is a very beautiful concept called SHAP, which comes from coalitional game theory. Feel free to look it up later, which helps explain which features were most responsible to get to the prediction that your model came up with. Very beautiful actually. So you should be, aware of how your machine learning model is working, especially in the age of AI. Um, I'm sure if the author wrote the book a few years later, there would be a lot of interesting examples on the basis of AI. So this was rule 7, and the link with the statistical notation is when you have something as simple as a linear regression as well, like we know y equals to alpha plus beta x. Maybe many of us have seen this before. But do we know how alpha and beta are actually predicted? That's the question that we should ask ourselves. In fact, beta is the slope and it's the covariance of the dependent and independent divided by the variance of independent. But just knowing the formula is not enough. What intuitively, what does that mean? What does it mean by scaling the covariance by the variance of the independent variable? So that is also something that we should, deep dive and look into. These questions are just one click away. You can know the answer with just a click, but we just have to put that extra 10-second effort to do that little extra research and understand things more. And personally, I believe in in our careers, it has a compounded effect in the sense that when you build this, it builds a sense of very strong reliability around you. If you are able to explain what you are doing, and you don't come across as vague or partially confident, it really builds trust, which has its own perks later. So this was rule 7. Rule 8 is don't take statistical bedrock for granted. Now, what does that mean? Maybe it's the most verbose of the rules mentioned over here. Let's see. And this the author pointed out very nice examples from various countries. Popularly known countries and even lesser known countries, in a relative sense, of course. Mm, that how the governments of the countries are often trying to control the statistical bodies that are gathering information, and you can very well estimate why they would want to do that, because if the public knows the truth, things can get messy if you are not an efficient ruling organization. So in 2018, the Puerto Rico, maybe I pronounced it wrong, Puerto Rican government was trying to, say that we are spending $1 million on, national statistics and whatnot. Let's just stop this because we want to save money. Now that raises the question that if you don't have an unbiased source of data collection, um, what can go wrong, right? Or rather, what is the benefit of having an organization or a body which gives you well organized uh, statistical data and records without any political agenda or such? It's unbiased. So the US or UK government has something similar called the Congressional Budget Office, which is like their national statistical agency in some sense, to take good record of the data. And they did this simple math, that they have around a $4 trillion, um, I would want to say economy or GDP. I'm not very well versed with the economic terms, but yeah, $4 trillion economy, let's say. Out of that, $50 million are being used to fund this statistical agency. And when we put it in perspective, because maybe we are not very much familiar with the scale of trillions and millions, at least I'm not. If you have $80,000, you are spending just $1 you are investing $1 to know how to spend the rest of the $79,999. So think about it like this. If you have $80,000 to invest and you want to make a very well informed decision, how much percentage of that money would you, sacrifice to get that information? Maybe around 10-20%, uh, maybe even 5%. Uh, because if your 5% investment is helping you invest the rest of the money better, the compounded return will more than justify the initial investment on gathering data. This really brings out this essence of what is that quotation? Knowledge is power. That kind of thing. Like if you have a source of good knowledge, in this case good statistical knowledge, then it could be a very powerful thing. And I personally feel that this rule has futuristic connotations to it, as in when you, me, or anybody goes to a kind of leadership position, we should know the power of an unbiased statistical authority and how it can help us make very well informed decisions. So it's important to invest in these things. And maybe just this rule someday for somebody can be a catalyst to sustain their $1 billion empire. Who knows? So this was the eighth rule. And here is the statistical notation was quite simple. That is, respect the source of the data. Wherever the data is coming, you respect the source. And in a sense, respect also here implies that you try to build credible sources of information providing faculties. This was rule eight, pretty simple, uh, but very well grounded, I would say. The ninth rule, this has a very beautiful case study to illustrate. It's that misinformation can be beautiful too. Now let's see through it. Now, speaking about information, let's first talk about misinformation. In this age, it is very easy to spread false information, rumors, or even something true gets distorted along the way. And yeah, no caption needed. The other thing is that even when we are trying to spread information which is accurate, which is true, the way we spread the information or the way we visualize the information for others to see can be very important. So something that you can do offline is look at this YouTube video called Tetris. You may have played that game Tetris when we had those console-based gaming handles. Blocks are falling down. You have to arrange them in pieces. So the animation is very soothing and beautiful like that. Whatever block is falling down, its proportion in size is correlated with the sorry, it's proportionate to the amount of money that it is affected with. For instance, I see this middle block, second column, middle block. It's um, representing 25 billion UK pounds. So we can only imagine what that brown block was. But the point is, even though the visual is very good, even though the data is very true, what essentially it is doing, it's not making correct comparisons. So let's get into the case study. We'll understand the importance better. We may have heard of Florence Nightingale. At least in my school, I heard that she was a very renowned nurse. But what I was not told in the school, and I was told in the book, was that not only was she a revolutionary nurse, she was also a very good, I would call, uh, data-driven statistician. And this case study is about her. And yeah, it's also important to note that she was the first woman to be made a fellow of the Royal Statistical Society. So what exactly was happening was, in her timeline, I'm forgetting 19th century or 18th, maybe 19th. Yeah, 19th. So there was this war going on called the Crimean War, and a lot of soldiers were dying. And the higher authorities over there were, their mindset was death is inevitable in war. People die, soldiers die. So it's sad, but we can't do anything about it. But what Florence Nightingale, along with her partner, research partner, William Farr, did was that she did a very nice analysis of the data, that what exactly was causing the mortality rates to be so high. And maybe you all know that it turned out to be sanitation issues. But from the point of not knowing to the point of knowing that it was sanitation based issues, um, it took a lot of research, because right now we know that sanitation is important, so we have that hindsight bias. But imagine if you knew nothing about sanitation and you were completely confused. How would you go about it? More important than that, more than her research methodology, is how she chose to represent that research to the superiors, superiors in the sense the higher authorities of the chain of command, who were initially convinced that nothing can be changed, nothing can be done about it. So this is a very famous diagram. It's called the Rose diagram. So what you see on the right, it looks like a pie chart, but there is a very subtle nuance to this. You see that the right chart has bigger pies because the size of the pie is proportionate to the number of deaths. And the left side, which is the future, the right side was 1854 to 1855. Left side is 1855 to 1856. The size is small, which means less number of deaths. So when somebody sees the graph, it really, the thing that strikes is, okay, the numbers, the size was bigger over here, and the size is smaller over there. And this really creates a nice impact, a nice psychological impact, that yeah, the numbers are coming down. She could have just made a simple pie chart of both sizes, but maybe, you never know. In the meeting, the people, when they saw the diagram, what clicked to them was this size thing only. And maybe a pie chart wouldn't have done it. I have had personal experience where I feel I have done good analysis, but the way I choose to represent that analysis makes all the difference. Because the point is, at least in corporate, you have very limited time in meetings to make your point through. So if your visualization is not very well thought, it can, not give you the outcome which your data is clearly implying, because that's just how things work, perhaps in a rushed environment. So this was the visualization part was incredible. So she represented the data in a way that was very well suited to make an impact. And this is what we are taking away from this case study. The analysis itself was very good as well. You can research on it later if you want. And here are some nice words on visualization, because I think this is something that may impact our careers a lot, whether we are in academia or corporate. We have to make an impression with our content and visualization in that little span of time that we have. Otherwise, even if your data is pointing to the correct direction, you may not be able to create an impact in the minds of the people who are actually going to take that decision. So, first, decide what you want to say with a graph. This is We get overwhelmed, I think, when in our college courses we are shown all of these fancy graphs. We just feel, let's just put all of them in the chart and people will like it. It doesn't work like that, because people have less time. They want to consume the information as fast as possible. So first decide the message that you want to give. And tune it accordingly. A good chart is not just an illustration, it is a visual argument. Sounds very nice. I haven't digested its intensity completely, so I'll not speak much on it. And the quote by Florence Nightingale herself, because her journey was not easy. She had to face a lot of opposition along the way. Whenever, and naturally that made her angry. So her quote, which I very much liked, was, "Whenever I'm infuriated, I revenge myself with a new diagram." As in career also, we can take some guidance from her. Whenever we are feeling very angry or something, channel that anger into constructive things, maybe to upskill yourself or something like that. She was upskilling, right? New diagram means new capabilities for visualization, so upskilling. She was channeling her anger into upskilling. Beautiful. So this was the ninth rule. Remember that misinformation can be beautiful too. So remember to visualize and represent the information correctly. Because very many fancy diagrams out there, they look very beautiful, but if you introspect them deeply, things may not make sense. And this is the statistical notation bit that I have. So if you have a sample of, say, this kind of uniform distribution, you have two estimators that can get you to estimate theta. The negative of the first order statistic and the last order statistic, both. But depending upon the context and constraints, maybe one estimator will be better than the other to make your case. And that is what uh, I tried to illustrate over here, that you will have a lot of correct data, but maybe at the end, at that very final meeting, to your stakeholders, to your bosses, to your professor, research dissertation, that one well thought representation of the intense analysis that you have done can make all the difference. So visualize information correctly and remember that misinformation is also very fancy, but it doesn't get you to the places where you want to go. So these were the 10 rules, but wait, what is the 10th rule? I didn't discuss the 10th rule, right? So essentially, the 10th rule is something. For that, we'll have to go to the appendix. The 10th rule is keep an open mind. That's literally what the rule is in the book itself. The chapter name is keep an open mind. And sounds very philosophical, perhaps the most philosophical rule. But, and I'm not going into it right now, but there's a very good case study of two very famous economists in the 20th century. The first one had a lot of, fancy degrees, if I have to put it like that. Uh, and he, I think, also won some very prestigious prize or something. Or in his time, he was very famous. I'm forgetting the name. But despite the problem is, and this is what happens when we somehow achieve or know a lot, we think that we know a lot. Whereas the ancient wisdom has always been, you must know enough to know that you know nothing, stuff like that. And it may seem an exaggeration, but when we have this tendency to feeling entitled to knowing a bulky piece of the puzzle or almost knowing everything, we shun off inputs that are pointing us to the other direction. And that can cost us a lot of bad business decisions, which was what happened to that economist as well. Whereas the other person kept an open mind when there was the Great Depression in the 1930s and all that. Both of them went through that. The first person was obstinate, the other person was flexible, and he was willing to adapt to what the data was showing him. And that's how it helped. But the point is, why can't we always keep an open mind? And that's where I would like to bring a little bit of spiritual stuff from the Bhagavad Gita. This shlok from the 27th verse of the third chapter. Prakrite kriyamanaani gune karmani sarvasa ahankara vimudhatma kartaham iti manyate. So Krishna is essentially saying over here that it's the ego. It's the false ego that makes one believe that one is very much in control of the things around them. And this is one of the biggest illusions philosophically and perhaps factually as well. Because let's say about even clearing competitive exams, it's if you really think about it, I have thought a lot about it. The fact that you cleared a competitive exam doesn't necessarily speak a lot about your own relative prowess. It could very well be that people who were smarter than you had a bad day. And it's a maybe it's a crude example, but it's a very intense example to me, that it's not always our so-called qualities and abilities that are the deciding factor alone. They do play a role, but there are a lot of things beyond our control. And it's just having this kind of mindset that there are a lot of things beyond my control helps us to be more open-minded. So to be a good analyst, you have to keep an open mind, and to keep an open mind, you have to reduce your ego, and you have to become spiritual. So in order to become a good analyst, you have to become a good spiritualist. That is what I'm to say to you over here. There is also a golden rule in the book towards the end, which is separate from the 10 rules, in which the author says the golden rule is be curious. Just be curious to know things. That is the golden rule outside the 10 rules that have been discussed in our sessions. And in that spirit, I'll request you all to keep the golden rule right now and mm, get curious about how to get rid of your ego or reduce your ego. Because this verse is essentially just telling that, yeah, getting rid of ego is important. But how do you get rid of your ego? Be curious, do your spiritual deep dives. Maybe the organizers will bring me back for something else, and we'll discuss more in the appendix in those sessions as well. I hope it was a good session, something that you could take away. And I'll end with a Hare Krishna. Uh, any questions, Hare Krishna? Any questions I would like to address? I can address if any questions are there.
I have a question from the last slide, like the previous slide.
Yeah,
That
sure.
like here you mentioned that like false ego and open mind, that two things. Can you repeat that? How these two are related? Like false ego and open mind, that like open mindedness and false ego.
Yeah. The false ego, or the ego in general terms, it essentially makes us think much more about ourselves or overestimate the control that we have on things. And with this sense of overestimation of our control, we get this bias, this subtle bias of this feeling that I know things. So consequently, we don't have that much of an open mind because of this very subtle outlook. But in contrast, a humble mind is more likely to be an open mind, because a humble mind is like foundationally, it acknowledges that it has a lot to know. And that mindset itself, is receptive for new information, and the mind is willing to change its preconceived notions when new data is flowing in. But the ego makes that a barrier.
Just one more thing, that you have written false. So like, is this different from ego, or like false ego is something and there is
Yeah,
something like
so yeah, in some spiritual schools of thought, including the one from where I took this snapshot, there is a perception, there is this notion that you have a false ego and a true ego. False ego is essentially all the layers of insecurities and whatnot, all the bad psychological stuff that you have built up since your childhood due to trauma or whatnot. Whereas your true ego or your true self is just very much unconditionally loving. And the entire spiritual process is to transform your false ego to this true ego of unconditionally loving self. Makes intuitive sense. Like, when you look at children, they don't seem very judgmental and all. It's these experiences in school, outside school, maybe family traditions that instill a sense of fear in them, and that layer of ego is built. So that's why the word false ego and true ego. And some schools of thought just call it ego, that you have to just destroy your ego. And when you don't have any ego, you are completely the original version of yourself. It's just a matter of terminology.
Okay, yeah, got it. Thank you.
Always nice to have questions, especially when they are spiritual. Ah, very nice. We started with rules to keep in mind for doing analysis, and we maybe ended with suggestions or rules to keep in mind for living life. That's good. That's a good flow of events. Anything else? Okay. Um, Feel free to reach out to me in case anything else is on your mind later. And Hare Krishna. Till then, yeah, this is the last slide. I'll stop sharing now. I Should I just end meeting for all?
Yes, I think. Let me just stop recording. Sure.